Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to the APSEX online sport program, subject chemistry, round 2, week 5. The textbook which is required is a textbook of chemistry grade 9 by National Book Foundation. Page number 45 to 47. Chapter number 3, periodic table and periodicity of properties. Topic: historical background, identification of periods and groups. Resources required are book, notebooks, pencils, pen and rough notebook. Introduction of the lesson. Periodic table means arrangement of the elements in a specific sequence. Following things will be covered in this week: historical background of periodic table and the identification of groups and periods through electronic configuration. Objectives of the lesson. At the end of the week, students will be able to know about the historical background of periodic table. They will be able to identify groups and periods through electronic configuration by solving multiple examples. What is periodic table? The periodic table, also known as the periodic table of element, is a tabular display of the chemical elements. Now we will discuss its background history described by John Newland and Dmitry Mendeleev. John Newland's concept. John Newland in 1864 arranged 24 elements in the order of increasing atomic masses. He noticed that every eighth element starting from any point has similar properties. Few rows of his table are shown on next page. This is Newland's law of octave. According to him, each element starting from any point has same properties with the eighth element. For example, lithium has the same property with sodium, and if we start with beryllium, it has same properties with magnesium. This is called Newland's law of octave. The word octaves come from word octa, which means 8. Drawbacks in John Newland's table. His scheme, however, failed because many of the elements were found out of the place. For instance, titanium doesn't resemble with carbon and silicon. Similarly, manganese doesn't resemble with nitrogen and phosphorus, and iron doesn't resemble with oxygen and sulfur. However, his arrangements of the elements in order of increasing atomic masses formed basis for later classification of elements. Mendeleev's concept. Mendeleev was a Russian chemist, and he also arranged elements on the basis of their atomic masses. At his time, more than 63 elements were discovered, which were arranged in groups and periods. According to Mendeleev's periodic law, if the elements are arranged in the increasing order of their atomic masses, then their properties are repeated in a periodic manner. Let us understand the meaning of periodic manner or periodicity. Periodicity means the tendency of an event to happen repeatedly in a fixed pattern. For example, if I consider an example from our daily life, illustration of moon phases exhibits the periodicity of moon. The moon changes its shape from time to time and repeats the pattern again and again. But when we talk about periodicity in our subject chemistry, it means the repetition of properties in regular intervals. For example, lithium and sodium both are reactive elements and they have shiny surfaces. Modern periodic law. After the discovery of the atomic number by Moseley in 1913, the basic unit of periodic table was changed from atomic mass to atomic number. According to modern periodic law, if the elements are arranged according to the increasing order of their atomic number, their properties are repeated in periodic manner. Here question arises in our mind: why atomic number, not mass number? Because some of the elements in periodic table have some isotopes, and isotopes or the elements, they have same atomic number but different mass number. So it is, as a chemist, were having difficulty in placing all the isotopes of elements on the basis of their atomic masses, but it was easier to place them on the basis of their atomic number, as all the isotopes of an element have same atomic number. So that's why they thought the basic unit of periodic table must be changed from atomic mass to atomic number. Electronic configuration. Electronic configuration is the arrangement of electrons in different subshells. For example, if an element has valence shell electronic configuration ns2, then small n is a number of shell, s is the subshell, and 2 is the valence electron number. As we know that there are 4 subshells, S, P, D and F. S subshell can accommodate maximum 2 electrons, P subshell can have maximum 6 electrons, D subshell can have maximum 10 electrons, and F subshell can have maximum 14 electrons. So how are we going to fill the electrons in the subshells? We have going to follow the Aufbau principle, which states that the electrons will fill the lowest subshell that is available first. So first we are going to fill the subshell of the first shell, that is 1s. When first shell will be complete, then the electron can move on the second subshell, and when the second subshell completes, the electron can move on the third subshell, and so on. This is the filling of the electron in the subshell. Identification of groups and periods. Following points must be kept in mind while finding groups and periods. The periods of an element relates the number of valence shell of a given element. Valence shell means the last shell of any atom. The group of an element relates to the number of valence electrons of a given element. Let's take an example of chlorine. Its atomic number is 17. Its electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p5. As we can see that there are 7 valence electrons in this case, 2 plus 5. So group number will be 7th A. The valence shell number is M. Is the 3m shell. In this case, therefore, the period of the given element is third. So we can say that the chlorine is present in third period of group 7th A. Example 3.1, page number 45. Identify the groups and periods of aluminium, boron, magnesium on the basis of electronic configuration. Problem solving strategy. Write electronic configuration of element, identify its valence shell. Remember that n value of the valence shell indicates period. Total number of electrons in the valence shells represents group number. Solution. Number 1 is aluminium. Its atomic number is 13 and its mass number is 27. So its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p1. Valence shell is M, as N is 3. Aluminium is present in third period. Since total number of electrons in the valence subshell is 2 plus 1 is equal to 3, it must be present in group 3rd A. Boron, its atomic number is 5 and its mass number is 9. Electron configuration of boron is 1s2, 2s2 and 2p1. Valence shell is L. So N is equal to 2. Boron is present in the second period. Since total number of electrons in the valence shell are 2 plus 1 is equal to 3, it must be present in group 3rd. Magnesium, its atomic number is 12 and its mass number is 24 and its electronic configuration is 1s2, 2s2, 2p6, 3s2. So n is equal to 3. Magnesium is present in 3rd period since the total number of electrons in the valence shell are 2. It must be present in group 2nd. Thank you. That's all from my side.